In this lesson, we'll be looking at one of the more advanced concepts for word problems on the quantitative reasoning section of the GMAT Focus Edition, and that's going to be combinations and permutations. So first, let's define those terms, starting with a combination. That's going to be a selection of a number of items from a collection in which the order does not matter in terms of the selection. Now, a permutation is going to be a selection of a number of items from a collection in which the order does matter. And we have to understand what that n with an exclamation point means, and that is technically what is known as a factorial. And that is simply the product of n and all positive integers less than n. For instance, 5 factorial is going to be 5 times 4 times 3 times 2 times 1, which would be equal to 120. Now, the good news here is that you will not actually be tested on whether something is a combination or a permutation on this exam, so you don't really have to try to memorize these things. But oftentimes the way that you'll encounter solutions for combinations and permutations are going to involve what is known as choose notation, and that's the expressions that we've got here on the screen. And the one on the left is going to end up being our combination, and the one on the right is going to be our permutation. And the n is always going to refer to the number of items from which you can choose. The r is going to be the number of selections to be made in the collection. C is going to, of course, mean combination, and that's when order doesn't matter. And P is going to be for permutation when order does matter. And the way you can think about that is permutation and place have the same first letter, and that's often how folks create a mnemonic for permutations or when place matters. Now, a permutation with repetition is probably the most simple of our choose notations, and we've got the number of options as n, and then the number of selections as r. So let's look at an example. How many different combinations of 3 letters are there in the English alphabet? So there are 26 letters, so our n is 26. We have 3 selections, and it's just 26 to the third power, or 26 times 26 times 26 would be 17,576, because we don't take away one of the letters, and we know that AAA is one acceptable option, and BAA is different than ABA, even though they have the same actual values chosen. So simplest is a permutation with repetition. Now, when you have a permutation without repetition, that's when it starts to get a little bit more complex. N still means the number of options, R still means the number of selections. So this time we have to introduce that factorial notation. So another example, how many different ways can gold, silver, and bronze medals be awarded to the top 3 of 6 go-kart racers? So N is going to be the 6 racers, because that's the number of options. 3 is going to be our R for the number of selections, gold, silver, and bronze. And this is a permutation because if Bill comes in first and you hand Bill the bronze, Bill is going to be unhappy, which indicates that order does matter, and you always have to consider that logically. Then we write out the formula, 6 factorial over 6 minus 3 factorial. Always expand the factorial and cancel first. So you can see the 3, the 2, the 1 will cancel from the numerator and the denominator, which leaves only 6 times 5 times 4, or 30 times 4, and 120 ways that the gold, silver, and bronze could be awarded to those 6 go-kart racers. Now, we've got a combination without repetition. So that's when order doesn't matter in selection, and the formula changes ever so slightly. So this time we have n factorial over r factorial times n minus r factorial, where again, n is the number of options, r is the number of selections. So a slightly different example, how many different ways can 3 $25 gift cards be awarded to each of the top 3 of 6 go-kart racers? There are still 6 racers, there are still 3 selections, but now it's an identical $25 gift card, so we have a combination without repetition because no one can win 2 gift cards, and order doesn't matter in selection. Now, if Bill comes in first, second, or third, Bill gets a $25 gift card, so Bill doesn't care whether he'd come first, second, or third. So we plug into the formula as 6 factorial over 3 factorial times 6 minus 3 factorial. And once again, you'll want to cancel with before you process the entire fraction. So the 3, the 2, the 1 on the right-hand side will cancel out both. Then the 3 and the 2 in the denominator on the far left side will cancel out with the 6 in its entirety. leaving only 5 times 4 or 20 ways that the three $25 gift cards could be awarded to the top 3 of 6 go-kart racers. Then we start to get into the most complex, which is a combination where repetition is allowed. And the formula here is the quantity r plus n minus 1 factorial divided by r factorial times n minus 1 factorial. And once again, n is the number of options, r is the number of selections. So one more example. How many different ways can Brenda choose 2 scoops of ice cream from a selection of chocolate, vanilla, strawberry, and butter pecan? So n this time is 4 because there are the 4 flavors. And 2 is the number of selections with repeat scoops allowed because Brenda could theoretically have 2 vanilla scoops. So we'd plug it into the formula. 4 plus 2 minus 1 would be 5 factorial, all over 2 factorial times 4 minus 1, or 3 factorial. So you have 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Of course, the 3 times 2 times 1s cancel out from the numerator and the denominator. The 2 will cancel the 4 down to a 2, leaving just 5 times 2, which is 10 ways that Brenda could choose 2 scoops of ice cream when repetition is allowed. Now, you may be saying to yourself, I don't know if I can remember that formula. And if that's the case, it's certainly reasonable in my estimation. But you have to make sure you've got a finite and limited number of options, and you can often test that with the answer choices. So if your answer choices have fewer than 20 options, you might be able to just write out the outcomes as initials in an orderly fashion. You can see here, we could do CC, VV, SS, BB, 4 options where they just double up each of the scoops. Then you just start with chocolate, chocolate vanilla, chocolate strawberry, chocolate butter pecan. Those 3 add up to 7. Move on to the vanilla. We do vanilla strawberry and vanilla butter pecan. Then we know we've already captured the chocolate vanilla, vanilla strawberry, everything involving strawberry except for strawberry and butter pecan. And butter pecan has been captured by everything previously. So you just add up each of those possible outcomes and you get to the 10 in a slightly more intuitive way if you forget this formula in the moment. Now, let's talk about our full process using an example here on the left-hand side. So as always, we'll set up the scratch pad listing the choices vertically A through E first off. Then we're going to skip to the end of the problem to identify the sought value and label those choices. So here we see how many combinations of book report presenters would include Edward but not Fizbo. Wonderful. So just shorthand note, number of combos with E, W slash means with, not F equals, simple enough. Then we're going to read from the beginning, taking notes and setting up equations as we go. So Edward and Fizbo are in a class of 10 fourth graders. If the teacher is choosing 4 of the fourth graders to present a book report tomorrow, so we've got 10 options, we're going to select 4 of the children. So N is 10, R is 4 from our prior formulas that we saw. And we know that from the question, we're looking for the number of combinations of book report presenters that include E but do not include F. So must choose E, cannot choose F. So if you see a clear and obvious application of a choose notation formula, go ahead and do it. But if you don't, and I would advocate that in this situation with all of the different possibilities and we have to pick E, we can't pick F, it's probably going to be more intuitive and more certain as you're working through it, because the choose notation can be really unforgiving. If you make one mistake, you'll get the wrong outcome. Here, we're going to instead do a visual representation of the selection that's occurring using some spaces for those selections. So you're going to draw a space for each selection to be made and label any known restrictions. So in this case, we'd have 4 spots. We've got an E that must be E spot, and then the 3 not F spots is illustrated with an F with a strike through. Then you want to enter the number of options one at a time, starting with the most restrictive selection. And in this case, it's going to be the E. And we know there's only one Edward, so there's just a 1 that goes there. But then for the first non-Fizbo spot, there are only 8 children remaining. Because there were 10, we have selected E. We can't select F, so that's 10 minus 2 gives us the 8. Then it's going to be 7 that remain for the second non-Fizbo spot, and 6 that are for the final non-Fizbo spot. Then we have to consider, does order matter for selection? And if the answer is yes, you'll multiply straight across. But if the answer is no, we must divide by the number of equivalent available outcomes at the moment of selection. And in this case, order doesn't matter because it doesn't matter whether if Charles is one of the other 10 fourth graders, is selected second, third, or fourth. It's the same outcome of selecting Charles. So with that in mind, we have to divide by the number of equivalent outcomes at the moment of selection. So when the first non-FSBO student is chosen, there are 3 open spots that have the same outcome of that child being chosen. So you have 8 divided by 3. Then after that person is selected, you have 7 children who are not FSBO that could be selected still, divided by the 2 still open spots at that moment of selection. And then you have 6 divided by 1 for the last non-FSBO spot. So then you'll want to reduce your fractions and multiply across. So take the 3 and the 2, cancel out the entire 6, and we're left with just 8 times 7, which is 56, and our correct answer. So, working through the combinations and permutations process. First, carefully read the problem to determine if a clear and definitive choose formula is applicable. If the answer is yes, go ahead and use the formula to solve technically. If the answer is no, you'll draw the spaces for each selection to be made and label the restrictions. Then step 2, you'll place the number of available options at the moment of selection in each of those blanks. You'll start with the most restrictive blank, and you'll have to consider if there are possible different iterations if necessary. We'll see how that plays in a moment in our whiteboard. And then step 3, you want to consider whether order logically matters in the selection. If the answer is yes, you just multiply straight across. If the answer is no, you'll have to divide the number in each blank by the number of available equivalent outcomes at that moment of selection, reduce your fractions, and then multiply across. So let's head on over to the whiteboard and see how you will execute your scratch work for these higher end difficulty problem solving questions that you may encounter on the quantitative reasoning section of the GMAT Focus Edition. As always, we start by setting up the scratch work. We've got A through E. We put a little line over top. We've got real numbers, so we'll write 10, 20, 25, 50, and 60. Then we skip to the end, and we're being asked how many different combinations of books could she return in order to check out something new. So I'm just going to write number of combos as shorthand. So then we'll just take notes as we go. So Francesca has checked out 5 novels, so we'll just say N is going to be equal to 5. And 5 biographies, so B is going to be equal to 5 as well. If local library rules require that she return 3 of these books before she can check out anything new. So we know that the selections are going to be equal to 3. And at least 2 of the books must be novels. Okay, so we know that N has to be greater than 1. So this is when that iteration thing comes into play. So we know that there are going to be 3 selections to be made, but we could have either all of the books be novels or 2 of the books could be novels with 1 biography. And because of this either or outcome, I would say that the choose notation formulaic approach is probably going to be a little bit difficult to apply here. But we know that we can either choose 3 novels or we could choose 2 novels. And because of that either or structure, we're going to end up having to add the 2 numbers of possibilities together to get the total number of combinations. So then we just start with the top iteration, and we've got a novel for the first spot. So there are 5 novels available for selection at that moment of selection, but there are 3 open novel spots. So we have to divide by that 3 to make sure that there are no duplicative selections. Then our second novel spot is going to have 4 options, but only 2 opportunities to be selected. And then we've got 3 and 1 for the final spot. Then it's just a matter of canceling the 3 and the 3, the 2 and the 4 will become a 2, and it's just 5 times 2 is going to be 10 ways that Francesca could turn in all 3 novels. Now, The next option is a little bit different because now a biography comes into play. So there are still 5 novels at the moment of first novel selection, but now there are only 2 novel spots. Then there are going to be 4 novels, but only 1 novel spot. And then there are going to be the 5 biographies and only 1 biography spot. So now we can cancel our 2 and our 4 down to a 2, and it's just 5 times 2 is 10 times 5 is 50 ways that Francesca could turn in 2 novels and 1 biography. And of course, our last step, and be careful because 50 is sitting there as a trap, of course, as was 10. If we do 10 plus 50, that's going to be our 60 total combinations, which, of course, is choice E. So if you see a clear application of one of the choose notation formulas that we spoke about in this lesson, feel free to use it. If you don't see it, however, don't feel that combinations and permutations are beyond your capacity. Apply this space approach, and you still might be able to get some of these highest level difficulty problems in the quantitative reasoning section of the GMAT Focus Edition on your side of the correct ledger.